Okay, with solution stoichiometry, it's pretty much like the stoichiometry we've been doing all year. It is important not to use the dilution formula for these, M1V1 equals M2V2. It actually, if you're looking for a molarity or a volume and it's all 1-to-1 to 1-to-1 on the reaction, it does work. So I guess in that case you could, but generally you're not going to have a 1-to-1 to 1-to-1, so don't use that. Don't rely on that formula. Just do the stoichiometry. All right, so this one, I'm going to go through several different ones. As you're doing the worksheets, just go back to the video and look at what kind of problem it is. They are all a little different. They're the same and yet different. So in lab, if I were to have you add an aqueous solution of silver nitrate, remember that's the stuff that is toxic and turns your hands kind of moldy looking. If you mixed those two aqueous solutions together, you would get a precipitate of silver chloride. It's a white solid precipitate, and some leftover NaCl. Okay, so we want to balance the equation, and this one is 1-to-1 to 1-to-1. We are looking for not a concentration here. We're looking for something a little different. That's why reading is so important for these problems. We want to calculate the mass of AgCl. I'm also a big believer in writing out the equation, balancing it, and then writing beneath what's being asked and what's being given. So for AgNO3, we are told that we have, wow, quite a lot of it, 1.5 liters. And we're also told the concentration is that. All right, so again, I'm writing it right under what it said here. The first thing that you want to do is whatever you're given, whatever substance you're given both the molarity and the volume for, start there, all right, for all of the problems. So I'm going to start with this, and I have 0.100 moles per liter. That's what molarity is, so I'm going to just rewrite that big M as moles per liter. I'm then going to multiply by 1.5 liters, and remember, if that's given in milliliters, be careful of that. Convert that. Okay? And we're going to multiply that and get 0.15 moles. Now, this is the part that a lot of people forget to do, and this is the stoichiometry part. So we know that 1 mole of AgNO3 should make 1 mole of AgCl. Will it always be that nice little 1-to-1? Of course not. But just go through the process here, whatever that is, whatever number, we put that there, whatever coefficient, put that there. All right, so obviously with a 1-to-1, you're going to get 0.15 moles again, but now it's no longer AgNO3, it's AgCl. So then, just like we did before, we're simply going to add up what does a mole of AgCl weigh. Well, Cl is 35.5, and Ag is 127, and so we can add those two together, or 107.9, and we get 143.35. Okay? And so when we multiply that by 0.15, we get 21.5 grams of AgCl. Theoretically, that can be formed. And you remember when we did stoichiometry the first time, that is just theoretical. Probably won't get that. You can do a percent yield by taking what you actually get divided by this theoretical of 21.5 grams. Okay. This problem is similar. We're going to go ahead and write out a balanced equation. That's aqueous. We're going to do potassium chromate, which is kind of a yellow, pretty, also very toxic. Double displacement. Barium's going to go with chromate and form a precipitate. And potassium will go with nitrate, +1 -1, and remain aqueous. And then we have to balance the equation, and it will be 1-to-1 to 1-to-2. Okay, so again, with everything, after I write the equation, I balance the equation, I am going to go back and say, okay, calculate the mass of barium chromate. that forms when 3.50 times 10 to the negative 3. I'm going to go ahead and just write that out. And that's moles. Again, go back and read. And then that is dissolved into 265 milliliters of a 0.001 molar. Okay, so with all of these problems, we're going to start with the one that gives us both the concentration and the volume. All right, so I'm going to take the molarity, and instead of the big M, I'm going to go moles per liter. I'm going to multiply by 0.265 liters. Okay, and we're going to multiply this together, and we're going to get 265 moles. All right, now this is more important for the people taking this for S2S credit because it is a limiting reactant problem. But all I'm going to do here is I'm going to realize that I have 0.00265 moles of potassium chromate. I have 0.00350 moles of barium nitrate. It is a one-to-one relationship. I don't have to do anything fancy. I just have to look at these and go, okay, well, if this is a one-to-one relationship, I have more of this and less of this. This is my limiting reactant. So I'm going to take my limiting reactant. And again, I'm not going to put one like this on the test. I'm just going to, I could put one like the last one, but I want to put one like this one. At this point, it's just like the last problem where I found out how many moles I have. I'm going to say 1 mole of that will make 1 mole of the barium chromate. Okay, and we will get 0.00265 moles of barium chromate. And then what you want to do is to get it back to grams, because it says calculate the mass. Wow, do this so much better at school. And a mole of barium chromate, we're not a room here, but if you add up, and I definitely would go through and just for the practice, add up a barium, a chromium, 4 oxygens, you should get right around 253. It's supposed to go in there. Okay, so 253 times 0.00265, and theoretically what we should get is 0.67 grams of barium chromate. And again, that's theoretical. You could do it in lab. You could get the actual, divide by the theoretical, times 100, and that would be your percent yield. All right, so I will probably do this into 2 different videos, but neutralization reactions, they're the same as solution stoichiometry, but what we're going to specifically look at is an acid, which if you recall starts with an H something, and a base, which is something OH. So this could be like HCl, this could be like NaOH. And that's a very simplistic way of looking at an acid and a base, but you can study that more later. It's going to make a salt and a water. You remember those double displacement reactions. So the first thing I'm going to do here is I'm going to get a it's going to make the salt, and then it's going to make HOH, which is the liquid water. Remember, our net ionic was hydrogen ion plus hydroxide ion makes water. All right, so it says what volume of a 0.1 molar hydrochloric acid? So I'm going to go what volume? Okay. Neutralize 25.0 mils of a 0.35 molar. Okay, so like I said before, we're going to start with a thing where we have both the concentration and the volume. We're going to do our stoichiometry, and then we'll answer this question. So the first 2 steps for all of them are pretty similar. So I'm going to multiply, again, big M moles per liter. I'm going to multiply by 0.025 liters. Change that to 0.025. And then when you multiply those together, you're going to get 0.00875 moles of NaOH. Now, don't forget to do the stoichiometry. Again, I know this is pretty boring. We have to do one where it's up 2 to 3 or something like that. But 1 mole of sodium hydroxide will react with 1 mole of hydrochloric. And we're going to end up with the same, of course, 0.75 moles hydrochloric. So the first 2 steps, as you have seen, are pretty much similar. Now, this is the tricky part. Not super tricky, but somewhat tricky. You have a concentration here, and you need a volume. Well, if I have moles, what I'm going to do is I'm going to remember this 0.1 molar means 0.1 moles per liter. And all I'm going to do, again, you could set up a ratio, whatever, but what I'm going to do is say 0.1 molar, okay, 0.1 mole per liter. I'm just going to put it on the bottom because I want the moles to cancel. And I know this right here comes from this, 0.1 moles per liter. I'm just putting the 1 liter on top and I'm putting the moles on the bottom. And that's how you're going to get your answer there. So you're going to get 0.0875 liters or 87.5 milliliters. All right, so let's see the titrations for the next video.